next is Ulysses, who's going to introduce us to Nodysseus. Nodysseus. My bad. That even makes more sense than what I said. But they're both great names. It's awesome. So I love to feature side projects that people work on. I think it's a really fun thing to do at conferences. HalfStack itself is a side project. So it's like a side project about side projects. Very self-referential. It's good. Which dongle gate would you like?
I'm using this one, I think.
Okay. But it's not turning on. There. Oh, there it goes. It was just loose. It's on.
Oh, it's on. Good. Great.
Yes.
Cool.
Is that it?
Yeah.
All right. Let's give it up for Ulysses.
Hey, everyone. So my side project is that I was bored, and I wanted to seem smart, and so I made a programming language and named it after myself. This is Nodysseus. This is the first time I'm presenting this, so and it's going to be inside Nodysseus. So hopefully this goes okay. So Nodysseus. I'm going to go over some inspiration for it. I'm going to go over some motivations for it, and then I'm going to demo a bit, and then tell you about the future plans for it. So, a little bit about me. I am. Can you see this? Can you see this, by the way? Is that good, size-wise? Okay, cool, great, thank you. So I've been a freelance dev for a while. I keep coming back to JavaScript. I'm currently working at a visual effects company called Electric Theatre Collective. And I want to bring the lessons from the visual effects and from the game worlds and those tools into the software industry. So tools, there's a whole bunch of non-programmers who use tools, and they don't consider themselves programmers, but they make these really beautiful networks and they make really beautiful artwork using these tools, and then vice versa. So I want to bring the ideas from software development into the largely desktop-centric visual effects world, so that it's web first, accessible everywhere, all this kind of good stuff, and simple design. This is Nodysseus. It's got React-like syntax. There's only a static server, so one of the big things is that it's all in browser. There's no data stored anywhere else. You can script in JavaScript, and the HTML, JavaScript images for this are all stored in the browser's database. So some terminology. Graph is a collection of nodes and edges that define a program. This is a graph. A node is a node. It's like a unit of work, some function usually. An edge connects two nodes, and a subgraph is a graph that's contained in another graph. This is going to be important because different programs use different things, and I'm going to show a couple examples from other programs. That's that. Cool. So why build a new tool? A few reasons. I wanted a generic tool. I wanted something that was browser-based instead of desktop application, and I wanted to reduce complexity. So we have a generic tool. I'm going to try and move through these quickly so that we can get to a cool demo. So there's all of these tools that different places use. Oh, sorry, I skipped a whole section. Sorry about that. First time I'm presenting this. Bear with me. Inspiration. It draws from node-based editors elsewhere. So there's Touch Designer, Houdini, Max MSP, and then a bunch of others. I'll show Touch Designer first. So it's used for music and interactive performances. So a lot of lights and video screens and real-time performances like music concerts and stuff are driven by Touch Designer. It's got support for a wide range of devices all through Node interface, and it encourages Python and C++ scripting. That all happens through Node interface 2, so that somebody can build these things and then somebody else can use them. Houdini is the one I'm using the most at the moment. is used for visual effects. So a lot of the explosions you see in films and TV and stuff are done in Houdini. Is used by artists of all levels. So there's people who never code can use this. And the way it does that is it wraps up some complicated logic. So all of these papers about how to physically simulate explosions and things are all given like these nice. You can see on the top right these nice like sliders and just some values that are exposed. Then artists can play around with it and get feedback on what it looks like. And then it also allows users to create their own nodes from graphs, so that within a company, like the company I work at, I can make a thing, package it up, and give it to some artists to use. There's Max MSP. This is a tool for creating interactive software with a focus on music. It comes from kind of modular synthesizers, so they use patches, or they call it patches and stuff like that. And as you're programming, you can see these things, and they're really tangible in front of you as to what the code is actually doing. So I think that's really important and cool. And there are some others. We have Nuke, Blender, or Maya, and one that people might be familiar with is Unreal Engine and Unity. The two game development ones there, so Unreal Engine and Unity, they all actually have 2 to 5, I think, different node editors inside of them. Even on this one, you can see on the very right-hand side, that's actually a different way of connecting nodes and a different node editor than the stuff that's on the left and that's going into it. So it can be really, really confusing. So instead of having all of these, I was like, why don't we build something that is generic? So in the same way that we have text editors that can write in almost any language, in Python or JavaScript or whatever, although obviously the best one is JavaScript, there should be a node editor that can kind of interact with all of these programs so that people who are picking one up don't have to learn a whole nother one when they want to use a different part of the same software or when they want to use another software. One of the other nice things about it is that if you're creating a generic tool, then you find broadly applicable solutions instead of very domain-specific ones. Cool. So working in the browser, so browser-based. All of the tools that I shown were desktop applications, but Nodysseus is browser-based. One of the reasons is because every device has JavaScript to a certain extent, usually. The recent developments in the browser allow desktop-like application use. So there's storage, there's access to GPU, multi-threading. It's more usable if you're on the go, like if you're going from your phone and you want to make changes to a program. It's really, really annoying to kind of type into a text editor. And there's a bunch of libraries and stuff that you can use for JavaScript. So you can like easily pull them and make nodes for them without too much effort. And it can also be run on the server, which opens up possibilities there. So one of the ways to make it generic is by reducing complexity. So I'll go through these. There's limited node parameters. So these 3 things that you see up top are all there is. There's a value and a reference. Those are the 2 functional ones that change the way the node functions. And then a name that's kind of, you can just label things. Yeah. There's one output. So all of these nodes, it kind of gets a bit messy because they're grouped together, but they do all have one output instead of a whole bunch of different outputs, and they can be reused, kind of using some of the abstract syntax tree things that Leo was talking about. And so you don't really need multiple outputs. And because there's only one output, it can be laid out automatically. If you saw me opening and closing the different parts of this, it's relaying them out instead of dragging them around. And there's context-aware subgraphing. So when I, problem of demoing live. When I collapse this one, for example, it knows not to collapse this thing above it because this is a argument, into this thing. Yeah. I think that's kind of goes over the motivations and design for it. Now it's demo time. So I wanted to get to this fairly quickly because this, I think, is the more interesting part of this. There's some links to this. I think, yeah, if you want to take a look and noodle around, there's the, does that fill? Does that work for everyone? There's the code on the bottom and then an example one on the top. There's just sort of some an HTML example. Cool. So some of the built-in nodes. I'm just going to talk about these ones because I've been using them throughout. So we have object, creates an object using the inputs, like this thing here is an object. There's a HTML element which uses DOM types, props, and children to create an element on the page. Markdown converts text created in the Nodes editor to HTML. For example, this is creating, this is in Markdown, and I can edit this here, and then it goes to the HTML below it, and then it's passed into this node here. Store file, it stores an image in the browser's IndexedDB, so it's all local. And then HTML slide, which is what I've been using for this presentation, which bundles up a few HTML elements into creating a presentation slide. So those are some of the boring ones. I'll go to HTML slide briefly. Just to show, like, you can have CSS styles. These nodes coming off here are all CSS selectors with some values going into them. And you can do logic. So one of the important things about being able to run a programming language is to have flow control. So you have if with a predicate and a true or false. So it will choose which input to use based on the thing that's coming into it. It wouldn't be a tech demo with any sort of creative thing at all if it didn't have a, see if this works. No. That is very unfortunate. Is there, I am on the Wi-Fi. I'm going to try turning it off and on again. Nope. Let me see if I have it here. Sorry about this. So it wouldn't be a tech demo without everything breaking, and also there being a spinning cube. So there's a spinning cube for you. is 3JS. It's updating each frame. There's some nice little animations so that you know what it's doing. And for a more interesting one, we have this one. That because it's all HTML and CSS and stuff, you can put sliders in wherever, or make your own HTML elements. And then finally, I wanted to show an example. So these are all using 3JS, but I wanted to show an example. Good, this one's loaded now. I wanted to show an example using a live code tool, if it loads. Maybe it's not going to load. Okay, I'm going to try going back here. So one of the, I don't think I have it locally. Okay, there we go. So this is using a tool called Hydra that's used a lot in live coding performances, made by someone called Olivia Jack. And one of the nice things about building a generic tool is that you can have it interact with whatever language you want, and it provides a nice, so usually you would code this in code using kind of a JavaScript-like syntax. And you can also do some visual things that aren't possible easily in a text-based editor. So for example, I have the, you can see what each different node is doing as you go along. So this is some noise that's repeated, and that's colored, and then kaleidoscoped. Let me go back to the presentation. Future plans. It's still very much a work in progress. Soon I'll integrate more JavaScript libraries along with better 3JS implementation and WASM stuff. Plugins for external node editors. At the moment, I just do Touch Designer. I'm looking forward to doing collaborative editing for pair programming and live performances. So in a live performance, you could have two people editing the same sort of code and kind of making interfaces for each other, or working on different parts of the same graph. Built-in multi-threading support and some like sharing and saving options. Yeah, that's the presentation. The link is up at the top. Let me open up that one again. Yeah, thank you very much.
All right, that's freaking awesome. That's amazing. I love when you have like a low fidelity and super high fidelity talk all rolled in one. It's really impressive and really impressive project.